Hi folks, welcome to another episode of NYC CNC. This is my new truck box. Just picked one up. They're actually quite handy. It's nice to get some stuff out of the cab. So what does this have to do with machining? Well, here's what I got in mind. For the folks that subscribe to this channel, you've probably seen the videos I've done recently on making copper blanks for bullets. One of the next steps in that process is going to be hardening the dies, heat treating them in the home shop. I don't have a lot of experience doing that, so I thought this could be a fun project right here. This truck box is secured to the truck bed with 4 bolts. Those bolts are actually accessible, and while the reality is anybody could steal this thing if they really wanted to, that's, I think, a weak point with just a hacksaw. So let's remake these bolts out of some 01. We'll harden them up, and that'll be a nice little deterrent and a fun little project. Okay, let's see what thread pitch these are. I've got a thread gauge, and I am hoping these are not metric because it will be easier to remake this part if it is SAE. Okay, so they are finer pitch than 16. Let's see here. Oh, boom, got lucky. Okay, so 18. So let's see what we got. I wonder if that's 5/16. So we might get lucky here. Let's grab a 5/16 nut. That would be convenient. Yep. Okay, that's actually really nice. I was really thinking we were going to have to work with a Asian import metric part. Okay, so this will be pretty straightforward. Earlier I said 01, which is an oil hardening steel. I lied. Let's use a piece of W1, and here's why. I do have a piece of 01, but I'm going to save that one because from what I've been reading, the way we're going to do this, which is with an oxyacetylene torch, not with a heat treat oven, 01 is easier to get a good heat treat on, and I want to save that for a more important project. What we care about here, we don't really care about the actual Rockwell rating nor the thoroughness of the hardness. We just want this to be a deterrent, and it's a fun little project. So on that note, let's take a look. What we should see. So that files. It's actually a little harder than I thought. Let's see though. The real test would be take our hacksaw here. Yeah. Obviously, so if someone wanted to sneak in there with a hacksaw blade, they could cut this bolt pretty easy. So that's going to be our test: is can we make a new part and harden it so that the bandsaw or hacksaw blade just skips over it. So here's our piece of W1, and before we go over to the lathe, I wanted to mention, if anyone out there is looking for a good book on heat treating, I just read this book by William Bryson called Heat Treatment, Selection, and Application of Tool Seals, and really enjoyed it. It was great. There's a few chapters in the beginning that talk about heat treating methodologies and things you need to pay attention to, and then the rest of the book has chapters on each particular type of steel. We've got our piece of W1 in the chuck here. I was actually just working on another project where I had to use a 5C collet. I don't have a 5C chuck yet for this lathe, so I just used my old 5C chuck inside the forge jaw and had it indicated in, so it'll work fine. The further out you move things, the less rigid they may be. Not too worried about it here. The plan of attack, we're going to face off the end of this, and we're going to spot drill it, and then we're going to use a center in our tailstock to hold that, because when we turn this down to 300 thou before we thread, it'll be thin enough where I want some support, and then I also want support while we're threading. Oh, that's a great surface finish. Can't complain about that. Let's throw a center drill in here and get our center drill ready. Make sure that's deep enough. And it's not. We'll actually go ahead and use the larger size center drill here. Although what I do need to remember is we're going down to 300. Yeah, that's 3/16. That'll be okay. Good, that'll work. Use a little dab of motor oil here in our dead center. Okay, now the question is, do I have enough travel? So let's go back to here. Okay. I'm still relatively new to this lathe, especially with a tailstock work, so I want to just triple check all my clearances. So that'll let me should come in far enough. We'll see. Okay, let's turn some tool steel. We'll take a 50 thou pass and see how that does. Sounds, you know, like there's no strain at all. I don't like this rat's nest though that's forming, or bird's nest rather. See if that breaks it. Yeah, that did the trick. I just stopped the power feed there for a minute. I forget where my line is. I scribed a little line there that I'll be able to see. You probably can't see it on the camera. I need to make a little chip hook here. To get this out of here. You don't want to grab these while the lathe is turning. Absolutely bad idea. Even this can be sharp. Okay. Okay, let's come in 100 and see how we do. Okay, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'm gonna come back. That looks a little much. Let's try 75. no chatter. You can see the chip is almost a straw color, so it's coming off pretty darn hot. Just fine. In fact, they're turning blue. Same thing. Now you don't want to touch these. I bet these are hotter than B. Yeah, you can feel the heat. Back the tailstock off. Okay, well you guys get the idea. I'm not going to have any problem taking 75 thou depth of cut passes. I'm going to finish turning this down to 300 and I'll be right back. Had no problem turning the rest of that down. We've now got our shaft at 300. I left a larger portion here at the end to give us sufficient meat on our dead center. And also I took a look in the truck box, and this screw in the truck box had almost ½ inch of excess thread. So no need to turn all that. So what we'll do is we'll thread the portion that you see right here, from here to our thread relief area, and then we'll part off or cut off this later. Also wanted to note, you can see the two lock lines here. I moved those over from the mill. I use a Trico unit, you can see right there, for my Tormach mill, which I really like. We've got our compound set at 29.5 degrees. We've got our thread dial set up. We've got the gears selected to cut 18 threads per inch. Let's cut a shallow test thread here and make sure we've got everything looks good, and then we'll start. You can see we've got a little run out in our part. That's okay, it must have flexed in the middle. That's 18 threads per inch though, so let's go ahead and I'm going to turn it up a little faster and cut some threads. No problem threading this stuff. You guys are here to see heat treating though, so I'm going to finish this off camera and I'll be back in a second. Threads are cut, they look good. Actually, to be honest, they don't look great. This high-speed steel threading tool I use is the only one I've got for this lathe, and I don't like how it tends to tear a little, so I may need to play with sharpening it, or I need to pick up a carbide insert threading tip. But for this, it's fine. I did a quick check. We need to turn this relief shaft area here down to 260, so that's 20 thou off per side. So we'll do that real quick, and then we'll hop over to the mill to cut a hex head for our bolt. Oh, actually, first I wanted to file down these threads. I always like to do that. Then I like to grab a piece of Scotch-Brite. Perfect. Just rounds them off if you don't want them too sharp. We'll go back up to full speed and let's come in and take that last 20 thou. We're touching, we got to move our tool here. Okay. There's 20, tooling on our coolant. Looks good. I moved the piece out in the collet to give us enough room, and now we're going to part it off. Perfect. There we go. Let's go cut the end off on the bandsaw and hop over to the mill. Let's model the bolt head up real quick in a Libre. I'm not going to walk through every step of this verbally. Oops. We're going to do, there we go, 555 and extrude to 0.3. Okay, that's enough. Save that. Let's import it into Sprute Cam. I'm going to use tool 30, which I happen to know is a 1/4 inch end mill, and according to GWizard we'll do it at 1505. We will come in and out with an arc, go down to 0.3. We're going to step it 0.05. We'll take a finish pass at the bottom, and that should do it. Now all I want to do is reset where it comes in and out, and do a quickie. Looks good. I cut the end off with the bandsaw and then just ground it down on the belt sander real quick. Let's check our thread fit now. Make sure that's good. Perfect. It's actually a really nice fit. Just ever so slight amount of play. But happy with that? Okay, we're going to throw it in the 5C collet and then machine the head. Okay, we know this is center because we indicated off these two sides and we know the dimension of the 5C collet holder. Now I'm going to switch over to my end mill, face off the top, and run the program. Okay. Okay, that looks great. Let's go the extra mile though. Let's put a little chamfer around here. Okay, let's throw in our 90-degree end mill. I'm probably babying this cut more than need be, but that's okay. Okay, let's zoom in here. Not a bad looking part, if I don't mind saying so. Okay, here is my plan of attack. I've got my acetylene tanks out. I've got the part set up on a steel bucket. What we're going to do is we're going to heat it up to critical temp. Should be a nice bright cherry red. We can confirm that it's at critical by using a magnet. The part will lose magnetism when it's at critical. We're then going to quench it as quickly as we can in the water, and that will harden it, but it'll be really brittle then, and I'll talk about that actually at the end of this video. I just ruined one of these because I didn't temper it back out. So once we've quenched it, we'll use a wire wheel and get the scale off, and then we're going to temper it. So we'll heat it back up to, I think the book says about 350, and then we'll let it air cool over time. So just no water involved. If you don't have an oxyacetylene tanks, I believe any source of heat will work. So propane, or Home Depot sells little MAP torches that aren't too expensive. The only thing I wanted to mention is obviously be safe. I'm doing this outdoors, and I will wear some gloves just for safety reasons. When you go to quench it in the water, don't have your hand or your head over the part. Reach out and dunk it in. Here we go. Okay, real quick, here's the part right out of the water. I'm going to run inside here and run it on a wire wheel just to clean up the scale, and then we'll come out and we'll temper it. The wire wheel did a nice job of knocking the scale off the part, so no problem there. So now what we're going to do is use the torch, and we're just going to try to heat it up to about 300 degrees or so and then let it cool. That's not too much heat, and for me this is actually going to be a little bit of guesswork. So we're just going to try it and see. So we're going to let that cool and see how we did. Here's our part. Let's make sure our nut still fits. Yep, that's good. Test our socket. Yep, that's a nice fit. Now, here's the interesting thing. Here's the first one I heat treated, and I didn't temper it. And I was testing, as you can see here in the video footage, and sure enough the hacksaw skipped right over it, which was great. And then a couple of tests with an automatic center punch and it snapped. And that was a good lesson learned. You really have to temper these things. I'm also told that W1 is a little bit of a trickier steel to heat treat, and because it has such a high carbon content, it can become quite brittle. So it's amazing to see something so strong become so brittle. So let's take our tempered piece and let's do our hacksaw test. Skipping right over that, perfect. Now let's see if we snap this when we use a center punch. I think if it's going to snap, it would snap at where I'm sure there's a stress riser where the threads end. Doesn't seem to be though. Try it from another side. Perfect. Well, let me know what you guys think. I'm sure there are some folks hopefully watching this who have more experience with heat treating than I do. I have to say this certainly passes my test of wanting to get a bolt on my truck box that is not going to be easily susceptible to a hacksaw. So mission accomplished on that front. More to learn, more to come. My next project is going to be working with O1, which I think is a little bit easier to heat treat. And I'm going to do that for the project again on drawing dies for copper jacket bullets. If you've liked this, give it a thumbs up. Otherwise, take care, folks. See you soon.